All right, welcome. We're looking at ACT Worksheet 210. We'll look at what's probably already very familiar, which is averages, median, mode, and range. But we'll look specifically how the SAT, or sorry, not the SAT, how the ACT can present these in various situations and kind of a best approach to take towards these problems. And we'll also talk about what standard deviation is. Not a common concept on the ACT, but it does come up here and there. I'd say maybe 1 out of every 5 tests, and would hate to see you miss a question just because you're not familiar with the concept. So we'll cover what standard deviation is as well. And luckily, you don't need to know how to calculate it. You just need to understand the concept to be able to get the problems on this test. Okay, so there's a very important thing that you need to know about average problems. And the rule that I have is I know you know how to calculate them, right? Average is the sum of all numbers divided by the number of numbers. So if I wanted to know my average amount of points per game, I would add up the number of points I had every game, and I would divide it by the number of games, and that would get me my average points per game. Right, just total points over total games. And whatever comes before the per is always in the numerator, after is in the denominator. So like, let's say I scored 10 points, then I scored 20 points, and then I scored 0 points. It was really that poorly that third game. I would just add up my total points divided by 3, and I would know that I had an average of 10 points a game. Okay, so anyway, that's simple enough, but what happens when it's not as straightforward? So let's quickly look at this example, and you'll see how just using this skeleton of filling in what you know and then figuring out what you don't comes into play. And also feel free to pause and read and try this problem on your own. I'll actually zoom up so you don't see the answer. Okay, so when Kevin Durant plays, 19 points per player is the average for the starting 5 players. When Kevin Durant sits out, his replacement and the 4 other players average 16 points per game. What is the difference between Kevin Durant's average points per game and his replacement players' points per game? So what we'll do is we won't get bogged down in trying to figure this out all at once. We'll just fill in what we know. So we know that with Durant, that the average is 19, and we know that we don't know the sum. We do not know the sum of all the points, but we know that it's a starting 5. So really what we can figure out is that the sum is actually 95. So we do figure out what we don't know. So now we actually have all 3 pieces. We have the sum of the terms, the number of terms, which is 5. We have 5 players playing that create this sum, right? This comes from 5 players. And we have the average. So we filled in all the pieces. Let's do the same without Durant. So this is without Durant on this side. So without Durant, we know that the average actually drops down to 16. And we don't know the sum, but we know that there is a starting 5. So now we're looking at 80. So the question, now that we've figured out all the pieces, we know the mean, right, for each one. We know the sum of all the terms. We calculated that for each one. And we already knew the number of terms for each was 5. The question wants to know, what is the difference between Durant's average points per game and his replacement player's average points per game? Well, when Durant doesn't play, they score 15 points less. So the difference between what he scores and what his replacement player scores must be 15. So it seemed like there was a lot going on, but it's really simple on these average problems to just kind of set up this skeleton, put in what you do know, and then go and attack what you don't know. Let's look at another average problem where we'll want to use the skeleton. Okay, so this example right here, and I'll keep it kind of up high so that you don't see the answers. And again, you can pause and try this out if you'd like. So in Miss Full House's biology class, the final counts for double the amount of the other 5 tests during the course. If John Stamos has an average or a 76 average prior to the final, what's the lowest he can score on the final to average at least an 80 for the year? So we want John Stamos to be scoring an 80 or above, right? So his average has to be greater than or equal to 80. With average, it's always sum of terms, so adding up all the terms divided by number of terms, right? It's always total sum divided by total number of terms. So if we think about this one, he's going to have 5 tests. So he's going to have 5 terms, but then he's going to have a final that counts for double. So what we do is we actually count the final as if it's 2 terms because it's going to carry twice the weight. Okay. Then he has a 76 prior to the final. So we can figure out the sum of the first 5 tests. So what it would be is we have his average is 76. We're just filling in what we know, and 5 tests. So 5 times 76, 380. So the sum of John Stamos' first 5 tests is 380. So he's at 380, and then he's going to take a test that counts for double. So we'll call that test X, but it's going to count 2 times. So that's the way we do it. If you're curious, you may be saying to yourself, why don't we just multiply the test by 2 and divide by 6? In other words, say I take a test that is, so say I take one test, it's 80 points, and then the next test I take is worth double, and it's 100 points. So the question you may be asking is, why don't I just call this 200, right? Because it's double. Why don't I just call it 200 and divide by 2, right? Why do I have to divide by 3 if the test counts as double? Why not this? And why is this one correct? And the reason why you go 80 plus 100 plus 100 divided by 3 is, if you think about it, on this one, I'd have 280 divided by 2. 280 divided by 2, we're looking at 140. You're not averaging 140 for the course, right? You can't average more than 100% on a test. So what happens when you count it as double, but you don't represent that in the denominator, is you get a skewed average. You get the wrong average. Whereas in this case, we have 280 divided by 3, and we get a 93.3. And that's something you could average, right, if 100 is the highest you can score. So going back to this problem we were looking at right here, if you think about it, he has 380 is what he has on his first set of tests. He takes a test that counts for double, so 2x, and then we have 7 in the denominator. So now all we have to do is isolate the 2x. So 80 times 7 is going to be 560, right? 80 times 7 to get that out of the denominator, because this is 7. So we have 380 plus 2x. It has to be greater than or equal to 560. Subtract 380 from that, and we're looking at 2x has to be greater than or equal to 180. So x has to be greater than or equal to 90. So John Stamos has to do well on that last test. Right, what's the lowest he can score on the final to average at least an 80 for the year? He has to score greater than or equal to a 90. So hopefully what you're noticing is that on these average problems, you know how to get average. It's something you've done your whole life. But on these problems, they give you bits and pieces, and you kind of have to use the skeleton. You set it up, fill in what you know, and you kind of have a visual there. And then you can start to attack what you don't know on these word problems. Okay, so median is just the number that's in the middle. If you need kind of more on that, you can read the explanation above, but I'm assuming most people feel pretty comfortable with median here. It's if you organize all the numbers in order, it's the one that's smack dab in the middle. And if you have an even number in the data set, so if you have 2, 4, 8, 12, 25, and 51, that's a data set of 6 numbers. So then if you cross off from highest to lowest and lowest to highest, you end up with these two numbers are in the middle. If you have an even number in the data set, you just take the number halfway between these two, or the average. So that's 10. So let's look at this example. What is the median number of bathrooms per household in the town of Springfield? Oh, okay. So if we look at this, we know that in Springfield, it looks like there is a total of 62 plus 18, so 78 plus 5, 83, plus another 4. So there's a total of 87 households. So if we lined up all the numbers in order, so we have 21s, so I do 1 20 times, 42 twos, right? If I lined up all the numbers in order, I'm going to have to cross off 43 of those numbers before I get to the 44th number, which would be the one right in the middle, if I have 87 numbers in total, right? So thinking about it that way, if I have 87 numbers in total, I'm going to have to cross off the lowest 43. I'm going to have to cross off 21s. So I cross off all my ones. And then I'm going to have to cross off 23 twos. So I'm not crossing off all my twos, but I'm crossing off 23 of them. So I'm going to be left with 19 twos. But my median number will be 2. Because once I've crossed off my lowest, my lowest 43, I've gone halfway and I'm still at 2. Hopefully that makes sense without having to write everything out. If you need to, though, write all the numbers out and you'll see. Okay. Here's a very common theme that I've seen on several tests. It says, so this example, in the following sequence, which two are equivalent? So it's really interesting. Your median is equal to your mean in any arithmetic sequence, meaning that if you see a pattern where you're counting up or counting down by the same number, then if you think about it, if you add all these up and divide by 5, you're going to get an average of 10. But your median is also 10. How do I know I'm going to get an average of 10? Well, if you think about it, I'm counting by 3s. 7 and 13 are a distance of 3 away from the middle. So they're going to average out to 10. Counting by 3s still, 3 and 16 are just 3 more away from the median number. So these are each 6 away. So 16 and 3 are also going to average out to 10. That should not be a 3. Ooh, that's a mistake. Major typo. That should be a 4. I was thinking in my head, I'm like, that's not going to work. This number should be a 4 here. I'm going to have to correct that. So if you're looking at this, so back to what we were saying, 4 is 6 away from 10. 16 is 6 away from 10. If you average them together, they're going to average 10, right? So whenever you're counting by a consistent number, any type of arithmetic sequence, your median and mean are going to be the same number. So that's D on this one. Hopefully that wasn't too confusing with that screw up. My apologies for that. Okay. Mode is just the number that occurs the most often. Sometimes you can have 2 modes. In this case, the modes would be 3 and 8. By the way, bimodal, if you have a bimodal graph, it would look like this. I saw this on a recent test, right? And pretend that this number is 10, and let's pretend this number is 25. This would be a bimodal graph. It has 2 humps or 2 modes. All right, anyway, range is the difference between your highest and lowest number. Let's talk standard deviation though. You do not need to know how to calculate it. What standard deviation is in a nutshell is it's how spread out your data is from the average. Okay, and a perfect example that I like to give is if I have a bunch of horse jockeys that are 5 feet tall, so let's say I have 2 horse jockeys that are 5 feet tall, and I have 2 basketball players that are 7 feet tall, the average height is going to be 6 feet. No one's near 6 feet, but that's going to be the average. If I have 4 brothers and 2 are 5'10", and 2 are 6'2", their average is also going to be 6 feet. Guess what, though? The standard deviation, or how much the data points are spread out from the average, is much smaller in this example to the left than this one. So this one has a low SD, standard deviation. This one would have a high standard deviation. So pause it and see if you can get this example right here, this one. I'm going to keep on going, but feel free to try it. So which of the 2 cities has a higher standard deviation in the 7-day forecast of temperatures? So you could try to calculate the average and then make a decision of which one is more spread out from the average. But just by looking at this, everything's clustered between 12 and 16 on this data set. This data set ranges from 10 to 26. And so the numbers on this one are going to be far more spread out from the average than the numbers on this one. So London is going to have, we know which one has a higher standard deviation. That's going to be Philadelphia. And there's more of an explanation here. Here's the average of both of them. If you're looking at Philadelphia, the average is 18.1. You're going all the way up to 26 and all the way down to 10. Whereas 13.2, you're only going from, so 18.1 and 13.2. So 13.2, you're only going up less than 3 to 16 and down less than 3 to 11. This one, you're going much further to get to 26 and much further to get to 10. So the data is just much more spread out for Philadelphia, so it has a higher standard deviation. Okay, now let's get down to business. Let's do some problems from previous tests. I've picked about 5 that are emblematic of kind of what you need to know. We may do all 5 or we may do 4 of them. We'll see how time's going. So 8, the mean of a list of 7 numbers is 85. The first 6 numbers on the list are as follows. What is the 7th number on the list? So let's do the skeleton. So we'll do the sum divided by the number of terms. So total sum divided by number of terms equals average. And then we'll just fill in what we know. So we've got 7 numbers, and the average is 85. And all of these numbers added together, get the calculator going. 82 plus 93 plus 68 plus 93 plus 70 plus 98. 504 is what the first 6 terms add up to. And then here's the 7th term. I'll put x for the 7th term. So now all we have to do is isolate x. 85 times 7, looking at 595. $595. So if we isolate x, I said 995. I thought that looked weird. Sorry about that. You're probably shouting at the screen. There we go. Okay, so x is going to be 91. And that's D. All right, let's on to the next one. All right, 19. This is a really cool one. I'm going to show you how to, feel free to pause it and give it a shot. I'm going to show you how to screw it up first, and then I'll do it the right way. There are 2 sections of Algebra 1 taught at the local high school. The average on the final exam for the 20 students in the first section is 74. The average score on the final exam for the 25 students in the second section is 92. What is the average of the final exam scores in Algebra 1? So the mistake, if you're being kind of sloppy and lazy and not careful, the mistake to make is say, well, you have class 1 and class 2. The average of class 1 is 74. The average of class 2 is 92. You say easy. The average for all students is just going to be the average of both classes. and divide that by 2. So what you're looking at is 116 divided by 2. Not 116, 166. It's like there's no way that adds up to 116. 166 divided by 2. So you're looking at 83 here. That's wrong. And hopefully you kind of know why that's wrong, but I'll explain. The reason why that doesn't work is, and this is also why you want to make this skeleton always, is it's the average for both classes is going to be the total sum. You want to know the average per student. So it's the total sum divided by total number of students. That will get you the average per student. Class 2 has more students. It is 25 students. So class 2 is going to influence average a lot more than class 1. So the correct way to do this one would be that for class 1, we have 20 students that are averaging 74. So to get the sum, that's just going to be 20 times 74. So 740 times 2, that's going to be 1480. So 1480 is the sum for this one. And on this other one, we have 25 students averaging a 92. 25 times 92, we're looking at 2,300. So to really figure out the average, we need to do 1480 plus 2,300 to get the total sum, so total points, and we'll divide it by the total number of students, which is 45. And when we do that, we get an average of 84 for both classes, not 83. And sure enough, 83 is an answer, so you just have to be careful there. All right, 2 to 3 more problems. Let's take a look. I'm going to skip 24. Let's do, we'll do 26, 27, and 29. We can hit these ones pretty quickly. Okay, I'm going to draw out 26. Anything that's in an XY coordinate plane, it always helps to draw it out. And then I'm going to explain why I put this on the average worksheet. And feel free to pause it and give it a shot. It wants to know the midpoint of line AB. A is at 1218. So we'll call this point 1218. B is -4, 2. And we want to know what's halfway between these. What's the midpoint? So a couple ways to do this. I think the easiest way is actually to think of this like a right triangle and say, look, to get from -4 to 12, we have to travel along the x-axis. We have to travel along the x-axis a total of 16. So 8 is going to be the midway point. Traveling a distance of 8 from -4 puts us at 4. So this point right here is going to be 4. To travel from 2 to 18, we have to travel 16 up. Traveling half of 16 is 8. So traveling 8 up is going to put us at 10. So this point is going to have to be 410. Another way to do it, though, is to understand that the midpoint is just the average of your x's and y's. So you could do 12 plus -4 to get your x point divided by 2. So really that's just 8 divided by 2, and that gets you this 4 right here. And then to get the y, you can do exactly the same thing. So for the y, you can do 18 plus 2 divided by 2 to get the midpoint or the average of these two y points. 20 divided by 2 is 10. And sure enough, that's that point. Okay, pause for 27 and see if you know enough about standard deviation now to get this one. This is kind of a real good test to see if you have standard deviation. I'm just going to keep on going though. So Now's your last chance to pause. So let's know which data set has the greatest standard deviation. Here's your answer, A. Why did I do that so quickly? Why do I know that? Look how spread out your numbers are. So the average of this data set is going to be 5.5, but none of the numbers are anywhere near that. All these other data sets, the numbers are clustered much closer together. Okay, 29, I find it really helps to kind of read it and map things out. This was one of the last 15 problems from a test, so it's supposed to be harder. I don't think it's that bad, though. You'll see what you think. And feel free to pause again, but I'll keep on going. So the mean of the set of 5 numbers is 24. Okay, so let's just do what we always do. 42 plus 3 plus 11 plus 27 plus x, right? We're just setting up our skeleton, divided by 5 equals sum. So we can figure out what x is. 27 plus 3 is 30. 40 plus 42 is 72. 72 plus 11 is 83. So 83 plus x divided by 5 equals, ooh, why did I write sum there? Probably shouting at the screen again. Sorry, I'm being very sloppy. Is 24, which is the average, not the sum. So 5 times 24 is 120. So really, we have 83 plus x equals 120. That means that x has to be 37. Okay? And then the second data set, the median is 38. So if you remember, a median on an even data set has to be the average of the middle two numbers. So we have 8 at the bottom, 53 at the top. 29 is going to be the second number. How do I know that? Because my median is 38, which is 9 above 29. So what's my other number have to be? Well, if I'm going to get an average of 38, that means that 29 plus this number plus x divided by 2 has to be 38. You can solve that, but I'm just thinking, or not, but I'm just thinking kind of logically. 29 is 9 below 38, so x is going to have to be 9 above 38, which means x is going to have to be 47. So if we want x, or no, y. Why am I calling that x? I should be calling that y, because that's what the problem's calling it. So anyway, if we want x minus y, we're going to get negative 10, right? We're going to get 37 minus 47 is negative 10. Okay, I hope this video kind of helps. One, if you weren't familiar with standard deviation, you now feel okay with it. If you want to know how to calculate it, you can look it up, but you won't need it for the test. And also, hopefully now you feel like you have more of an approach for median, mean, and mode when it's presented in a word problem. Okay, well, good luck with this worksheet.